Hybrid Cloud Show, episode 22. I'm Aaron.
I'm Gary.
I'm Sean.
And I'm Shane.
Welcome to the show about public cloud, private cloud, and everything in between. Our views here are ours and not those of our employers.
So Sean and I were talking in our Signal group the other day about how you handle the differences between environments. And your example, Sean, was that in your home prod environment, you run your databases inside Kubernetes, which then caused you a bit of a bootstrap issue when you tried to restart some services because the storage wasn't up and the database couldn't start. But you needed something else to be up that needed the database in order to properly administer the cluster. And it all got to a little bit of a mess. And I guess we spun that out into a conversation about, well, how should you handle these lower environments? Because clearly you've mixed up home lab and home prod somewhat in order to end up in that situation. And I guess it got me thinking about clearly running your dev environment or your QA environment at the same scale and in the same way as production is not something you can always do. We talk about all of these best practices about production should be across multiple availability zones. Well, clearly that's something that is not so feasible to do in dev. And then we talk about things like your example, Sean, with your database. You might be running a really large Aurora database or something in production with loads of IOPS automatically provisioned on the disk so that you don't run into the same performance problems that you might in dev. And I guess my question is, what are the sort of things that we think about when splitting prod, dev, stage, UAT? And should we be as worried as we sometimes are about it?
Absolutely. What I heard from all this, what I learned is I need more computers. That way I can separate them out. That's what I heard.
Yep. Come on, I'm not your wife. You don't need to convince me of that.
No, but I think we absolutely should be concerned. And it takes a critical mind to really determine whether you need to separate something or scale it down. Can you afford to scale it down? For example, there are some databases that, you don't need 16 cores and 32 gigabytes. It's for dev. It doesn't see as much action, it doesn't need as many IOPS. That makes a lot of sense. But, for example, I ran into this issue one time where we did that, or we had a much smaller instance of a dev database than our production database. And whenever we ran our tests against the database to test performance, specifically because this was a very high throughput database, and we want to make sure that our transaction times were consistent. In dev, it worked, no problem. And we didn't see issues until we passed the scale that prod was at. And we wouldn't have caught that. So we needed to up our dev and up our cert databases. That way we could operate at the same scale to have real performance impacts, the same that we would expect in prod. Additionally, data sources are very important to me as well. For example, you might get a subset of data for like a dev or a cert environment than you would a prod. And sometimes that can cause problems with my dev in cert environments because I don't have all the data there. And so if a customer says, hey, this happened, it's really tough for me to go and replicate it because I don't have all the data. So it's very much a it depends kind of answer. And I think that's why we're paid to have that context and to understand when you can do that and when you can scale down.
Well, there's a bit of a broader point there around being clear what it is that you're testing at each stage. And if you know that you need to test both unit testing and integration testing or whatever, but you've got a gap around load testing, maybe that's something that you do separately, right? Maybe once a month you do load testing at the kind of level that exceeds production, or maybe you do have tests that will test your application across all the different instance types that you would expect to be used in that environment. But that's not something you're going to run on every Git commit. So just making sure that your test matrix understands where you're likely to fail and is a proportionate kind of representation of that.
And I think also what level of testing is appropriate, right? Because I worked in a place where we only did releases once a month. But what that resulted in is our test team or our QA team not fully trusting the release process and not fully trusting the platform and wanting to do a full regression test at every release every month. So it took our release time from an hour to about 3 days, right? While a group of 5 people went and tested every single aspect of our system that someone might possibly touch, and trying to get across to them that, like, this isn't a valid thing to do. It's running on different hardware, different deployments. It's running with, like you said, Sean, a subset of production data, most of which is not going to be valid. We've bought all sorts of shims and things we've put in there to just return a dummy image, for example, when you go to a product info page. It's not actually calling our S3 storage to go and get the live production image. So there's a whole bunch of things that could go wrong, even in the case where you've decided we're going to fully test this thing end to end.
Yeah, it can become quite political as well. The platforms you'll build might end up being a symptom of tech debt in other parts of the organization. Like if a bunch of different systems are all dependent on each other and also a central massive MySQL database, you're going to have to maintain and manage a big, massive MySQL database. Oh, and also they have no confidence of their tests in lower environments or any sort of production-like simulated data. So you're going to need to sync that down to lower environments every day. You can burn and spend a lot of time on the wrong thing sometimes. Like I've made decisions in the past where it's like, no, the engineers are going to feel some pain. This is going to suck for them a bit because they need to feel this pain. The platform can't solve everything, including all of the bad practices that they want to continue to enable. So sometimes it becomes a little bit of a like, you'll do enough, but then you want some pain elsewhere. So it's not only thinking about your team, but the tech organization as a whole.
Like Shane just said, sometimes your service depends on other services. And in an ideal world, you do some sort of integration or end-to-end test where you run your service against theirs or, make a call to theirs and make sure you get an appropriate response, stuff like that. Whose responsibility should it be to make sure that you're able to test your application against their stuff? Is it on you because you're the owner of the service, or is it on them because they should be providing you a place for you to accurately test your stuff? Because that's a very tough decision what we're dealing with right now.
Having felt this pain in the past, this needs to come from like tech leadership, and it almost needs to be like we're agreeing a responsibility across the board. What I've found has worked in the past is something like pack testing, so consumer-driven contract testing. So you're like not testing to an implementation of something, you're testing to an agreed interface. I, as a consumer of your service, expect you to adhere to this interface. If you break out my contract, your deployment will fail and you need to fix it. But it's my responsibility to make sure that contract's up to date. It needs to be something like that if you're going to do something healthy, in my mind. There may be other approaches, but something consistent where responsibility is agreed and it doesn't become this like costly political infighting type thing.
Yeah, it feels much easier to maintain interfaces or agreed kind of APIs or whatever that one party is keeping up to date, and then you're just relying on those being correct in your testing than to try and agree at the kind of testing level who is responsible for not breaking your tests, because that's always going to be a bit more political.
Yeah, I had someone ask in a Slack group on platform engineering, they were spinning up 50 services into an ephemeral environment, and no doubt running into issues where some services would just go down or be unreliable. And so your ephemeral environment or getting confident in that was wasted. And at that point, like you're building for this distributed monolith that needs architecturally decoupling, really. And something like this would help. But you can't solve every problem with a platform, I think.
Yeah, I think you bring up an interesting point there, right? About not building something that has these tightly coupled what you assume are microservices, but you're right, they do just become a big distributed monolith if they have these dependencies that if your API doesn't respond in this amount of time in this specific way, my application breaks. Maybe there's a design choice you made somewhere along the line there that you might want to try and architect your way out of. Not always possible if it's, like you say, a 20-odd-year-old application with a bunch of legacy and politics and my service was here first and your service is broken my service and everything else. But I think as engineers and I guess as architects is one of the things we have to be really careful of is defining what those inter-service communication things look like.
Yeah, it's sort of like when you're designing these things, like think about the scaffolding. Like what does this whole system need to keep things connected together, and what are the things you should care about while you're starting it off. It's easier said than done, and half the time we're dealing with systems that never thought about these things. But yes, in an ideal world, think about the scaffolding for whatever you're building.
On a kind of related note, have you guys ever heard of test containers?
I've tested stuff in containers.
No. So that's the idea, Shane. What test containers is basically just like a wrapper that you can plug into a bunch of different languages, whether that's Python, Java, PHP, something like that. And you can define like an integration test easily as part of your code. And so you can say, hey, as part of my code, I want to spin up a Postgres container and then, run these transactions against it. And then your application, whenever you do your testing, right, will spin up an actual live instance of your application and the container and then try to run those tests against it and then shut it all down. And it's a really nice, easy way to get some real integration level testing without having to go through the hoops of finding a lower environment and getting creds and all that stuff. So this has really helped us because we've been able to test against a live Postgres instance versus some kind of in-memory replacement like an H2 database. And that helps us catch, there's actually a problem with your schema and Liquid-Base couldn't apply this because of X reason. And you wouldn't have caught that if you were doing it on an H2 database versus a real Postgres database.
You're talking about effectively setting up your testing infrastructure inside the integration test in your code.
Exactly. And you can define it almost the same way you would as a unit test really easily. And just define, I want this pod on this port, and you can have whatever you need.
It's interesting. I've done things like that, but sort of at the other layer, and that normally you'd spin up the containers in like the GitLab pipeline or whatever and deal with it there. It seems interesting to me to do it inside the code of the integration test, but I can't see a huge conceptual problem with it.
It's made our life really easy, especially for things that are a little more complicated, like testing against like a Kafka instance or like a GCP pub sub. We're able to actually spin up an emulator or an actual Kafka instance or RabbitMQ, send our messages, and then, consume them on the other side. And that's a real integration test against a real service versus, trying to mock all that stuff out in a unit test.
I guess this is about shifting the entire testing pipeline left, right? We often talk about shifting security and those kind of things left, so they're earlier in that kind of pipeline. But yeah, like you say, the earlier you can catch those things, like my service is sending a malformed message to Rabbit or something, then the easier it makes it for you, right? If at build time, you just run an integration test and go, oh, that's sending a dodgy message. That's something that you otherwise wouldn't catch until you were trying to deploy into dev or something.
It's interesting because then you've got the kind of the complexity of setting up that environment in the integration test. So how do you manage things like configuration drift on your integration test version of Kafka versus your production version of Kafka?
I guess you decide what you're going to test, right? If you're testing for compatibility with a specific version of Kafka or a specific version of Postgres, you're never going to catch that locally because you're not going to run Aurora locally on your laptop in the Postgres and AWS world example. But what you are going to catch is, have I got the port wrong? Or does my query work? Those kind of things are the things that you want to catch earlier that are probably things that you mess up more often than a Postgres API changing completely from under you so that your query doesn't work or something.
Yeah, I suppose it's my point before from right back at me, right? Like you decide what you're testing.
Exactly. And the same tests that are going to run your pipeline are the same tests that's going to run on your local machine, right? When you do your unit test, there's no problem as long as you have Docker installed or Podman or something. It'll just spin up a container, and there should be no excuse for failing tests in a CI pipeline if you can run the exact same tests on your local machine in the exact same way with the same resources.
It literally has to work on your machine.
That's right. So I like that a lot better, and it helped us catch a bug where it was one of the official GCP libraries that we were using to talk to the pub subs in our Java application. And there was a version incompatibility that one of our developers upgraded thinking, oh, it's the latest version, I'll do it. But when they did that, it actually broke our ability to read pub sub messages. And we didn't know for a couple of days And that was a big problem. And when we added this integration test with an emulator, right? Not the real thing. Like Gary says, we can't run an actual pub sub instance, right? But when we test against the emulator, we were able to see, oh yeah, our application actually isn't receiving any messages from the pub sub, even though we've tried to publish to it. So these kinds of things can actually be helped, even though you're not running the real thing. This episode is sponsored by SysCloud. Companies big and small rely on a lot of SaaS applications to run their businesses. But what happens when critical SaaS data is lost due to human errors, accidental deletions, or ransomware attacks? That's where SysCloud comes in. It's a single pane of glass to back up all your critical SaaS applications, such as Microsoft 365, Google Workspace, Salesforce, Slack, HubSpot, QuickBooks Online, just to name a few. SysCloud also helps with ransomware recovery, identifies compliance gaps in your SaaS data, monitors for unusual data activity, and can automatically archive inactive SaaS data to save on storage costs. Plus, it's SOC 2 certified, so data remains secure in the cloud. Over 2,000 IT admins already trust SysCloud to protect their SaaS data. Head to syscloud.com for a 30-day free trial, and for a limited time, use code HCS to get 50% off your first purchase. That's syscloud.com.
Sean, you were just telling us about how you have moved from using GitOps to something else. And I encouraged you to hit record and then tell us exactly what that something else was and what the story was there.
Yeah, so recently within my org, we have kind of two competing platforms for Kubernetes. One is GKE based, and the other is on-premises. I think it uses, I want to say K3S and Rancher. And the on-prem version uses GitOps. The platform is designed around Argo, and it incorporates some other tools like Vault for your secret management, and it's a very turnkey solution that's very easy to onboard to. The trick is that you have to do things the way the platform wants, which is to use customize, and you have to have a specific repo that you tell the platform to look for. And we've used it for a couple years and had no problems until we did. And that caused a kerfuffle, if you will. And a lot of the pain points around that was we didn't know when we had a successful deployment or not. And the other issue was if I ended up deleting a resource out, it was never get cleaned up because it was just doing, customize, apply, and it never got deleted. And when I tried to enable, pruning or something for Argo CD, I wasn't allowed to do that because I'm not an admin on the platform. And so all this kind of came to a head, and we ended up switching over to the GKE version. And then instead of having GitOps pull our manifest, then we had customize, apply, and then we had Helm deploy the output of our customized files. And this was a clever little way that we were able to continue to use customize as, my team is comfortable with, but also get that like atomic transaction. So if I end up deleting a file or something, right, then Helm sees, oh, this isn't part of my resource anymore. It actually deletes it. And so we've gone from this pull model, pull my servers, pull my services in, to this push model of Helm install these manifests. And I was curious what you guys think about the GitOps model, and if you guys have had any pain points with it or heard of any elegant solutions around, not being notified when your deployments fail, because that was a big problem for us.
Before you get into that piece, guys, if we just cycle back a bit, what have you really gained from that change? Like, I just want to understand what changed about the way you're doing things and the practical output.
So with the push model here that we've got going on with Helm and Customize, we know when something fails, right? We push it. It tries to, as part of the CI pipeline, it tries to do a, Helm install. And if it doesn't, or something happens, then it rolls back automatically. And then, the CI pipeline fails and we get notified of that. So we have immediate feedback, whether something was successful or not. And with Argo, you don't get that. Unless you go to the UI or something, there's no notification, no webhook or anything that reaches out to our team to say your deployment failed or you have something outstanding.
And is that because you feel you couldn't do that in the other tooling, or it just wasn't something that you'd ever set up?
It wasn't available from the platform. I do run Argo in my own home lab, and I tried to recreate it myself, right? So I can show my platform teams, here's how you could do this and, help them get there. And I really struggled with it. I really couldn't get that webhook of a failed deployment to reach out to me in any kind of consistent manner.
Yeah, so then you're looking at some kind of monitoring or something else of the service, but at that point it's already unhappy and you've not got an automated rollback, so it's not quite as clean as the Helm.
It's not even that, because my service wouldn't even go down because Kubernetes had a rolling update policy, right? So my existing pods would just kind of sit there always up.
Yeah, okay. So unless you went into the Argo UI, you just didn't know.
You got it.
What's running the Helm install? Is that you're pushing still a commit and there's a synchronous CI action running the Helm commands?
Exactly right. It's just a simple build, test, and deploy.
So the helpful thing now is because it's a synchronous action, you're waiting for Helm to finish, and then you get that status message in your CI to say, I failed or succeeded, rather than it's pushed off into the ether, and then I'm waiting for something to come back around to give me a notification.
Exactly right. And we were even able to easily tie in a notification to Slack or something that our CI pipeline failed, right? That's just a given.
Yeah, so that's always been my preferred way of doing things, right? It's either that or you make a habit of moving away from the model of deploy on push, and someone goes in and does a manual release, either through CI or some other platform. But you go into Argo or Circle or Jenkins or whatever it is, and you go and consciously click the button when you know you've got a branch that's ready to be deployed to an environment. That way, you're probably going to watch the log files go past, or at least get a notification if there's a failure in there.
I feel like GitOps might not necessarily be the problem here. It's potentially some limitations with Argo more than anything. But another challenge I'm seeing with GitOps is the tooling is very repo based. And that's, particularly with microservices, not always the whole story. So I know with Circle CI, for example, there might be a pile of Circle CI jobs that are calling webhooks to call other Circle CI jobs because this microservice depends on this microservice updating. And it's just this really painful way of managing multiple systems. So I'm not sold on the tooling being particularly good. I think there should be better stuff out there. And I'm aware of some that we've looked into that are kind of more holistic, realistic. Here is your entire engine. You need to push a deploy here. Okay, well, these are the things dependent, and you've got a whole visualization. I can't remember the name of it now. It'll come to me. But yeah, I feel your pain on some of this tooling. It feels like it should be better. And a lot of the time, when I think about all the tech we work with, those pipelines are what I fight with the most and try to build something I want inside it rather than getting the solutions I want.
Yeah, and of course that's part of the problem, isn't it? That a lot of these CI platforms are sold as a one-size-fits-all solution, and you can do everything you need within the platform and it just works. And it just works on the basis that you have one service that you're building and deploying in a very specific way. And I think, like you said, Shane, when you get to those real-world requirements of, well, to deploy service A, I need to bounce service X after I've deployed it, and that requires a webhook into another pipeline that you're then maybe not monitoring quite so closely, or you're not properly capturing the output of to record the success of the second pipeline. This stuff gets really tricky really quickly at scale. And I've seen customers and companies work around it in so many different ways. I've got one company that I've worked with before that just have a mono repo, and that means that they have a single deployment pipeline for everything, and that is equally as painful, I think, in different ways, right? Because they get around some of the pain of, my pipeline needs to touch something in this repository, but it doesn't have access to it, and I need to kick off something else. But then they've got a multi-gig repo building a multi-gig container image, and it means that they can be a little bit less flexible about the types of deploys they're doing.
I've had one company I worked for where they tried to do mono repo, but it became really painful and slow to deploy. So we had to do this thing where we'd look at the git commit to be deployed and look at what files were changing, and then just did a subset deploy based on what the file. We were just building another CI system inside our CI system. It was a horrendous mess I inherited.
You're building the same problem at that point, right?
Yeah.
Because rather than calling off to other deploys in other repositories, you're monitoring which parts of the current repository have changed in order to trigger which pipeline you're going to run. So you're just building yourself into the same corner, I suppose.
Yeah, it was wild and wonderful.
That's a good point. I hadn't thought of that if you have like a monorepo and you have those dependencies, right? It's really easy to kind of say only, run this pipeline if these files change, right, within this folder or whatever. But it's really hard to do that in GitOps. I don't know how you would do that. Huh. My head hurts.
I don't want to think about this problem.
Well, I think that just about wraps things up. So before we do, I just want to say thank you to our existing PayPal supporters and patrons. If you want to join those people, you can at hybridcloudshow.com/support, where for various amounts on Patreon, you can get an ad-free feed of either just this show or all the Late Night Linux family shows. And sometimes you receive episodes early. If you have any questions or feedback for the show, please do send that in to show@hybridcloudshow.com. And we'll be back in 2 weeks. Until then, I've been Aaron.
I've been Gary.
I've been Sean.
And I've been Shane.
See you later.